welcome to our second technical vlog. In the previous vlog, a colleague and I discussed about the fuel cell battery hybrid systems, and in this vlog we will discuss some of the benefits of the system with our CTO Michael Glantz. So Michael, how do you envision the myFC's technology being beneficial to the society?
One of our big benefits is that we have a freedom of design which we normally don't see in applications like this. Our planar fuel cell, which is this is one of the parts that I think you showed in the last vlog you did. Out of this size we build arrays of fuel cell, which means that we can utilize volumes and space in a vehicle which normally not is available for a prismatic larger fuel cell stack. And that gives us an opportunity to integrate on a system level, which is a bit more deeper than what we've seen today.
So you're saying that we will achieve freedom of design with the planar fuel cells, right?
Yes, freedom of design gives us, what we call freedom of design is that we design our fuel cells into arrays, and those arrays are application dependent. Those arrays can be either designed according to customer requirements, if it's space or volume, or we can design them according to manufacturability, for example. And also our modular and planar designs allows for a totally different integration than what we see today.
So can you give me a little more technical details on how the planar fuel cells function?
Well, in our arrays, we basically multiply a smaller cell into a larger cell array where we can individually control either specifically a single cell in the array or the complete array itself, both with gas flows, hydrogen and oxygen, but also the power and energy output of the cell.
Okay, so what about the control and cooling of a fuel cell in the larger application?
What we know today, we use a air-cooled system, which is also a benefit when it comes to weight. We don't use a liquid cooling, which is beneficial. When it comes to control, we could basically control each individual array and either add or deduct arrays from the system as we need.
Mm-hmm. So would that also allow for better diagnostics of the fuel cells?
Yes, we could go in and control and diagnose each cell array or each cell even.
Mm-hmm.
So what that means is if there's maintenance, for example, needed, we could just take away one array instead of the whole fuel cell system.
So Michael, how do you visualize the fuel cell technology in an application?
Well, in an application, if it's a vehicle or any type of application, of course, we have a balance of plant, which means that we need to handle all subsystems in an installation or in an integration, which means that we have the hydrogen storage, we have safety, of course, we have thermal management, water management, we have the FCC, which is a fuel cell control. Mm-hmm. And by balancing all of those, we see that we can increase the overall system efficiency, not only the fuel cell system, but also the overall vehicle system, which means that we can, for example, harvest the heat or harvest the water that's generated in the fuel cell. That's two of the utilities besides electricity. Electricity is, of course, the main product that we're looking for in the fuel cell, where we convert hydrogen and oxygen into electricity. But by balancing those systems and subsystems, we can see that we have a potential of increasing the overall system's efficiency in a very good way. So I think that our technology in combination in an electrified vehicle, we can see a lot of benefits, not just the electricity, but also the utilities that generated from the fuel cell.
So thank you, Michael, for telling us about the fuel cell technology and your quick insights into system level integration of the fuel cell technology.
Thank you.
Thank you for listening.